Thanks everyone for joining our webinar today. I have the pleasure to host one of our speakers, Hyuk-Jeen Suh, today. And before I give an introduction to Mr. Suh, we want to welcome everyone. This is part of our MarketX webinar series. We will host this every week, probably around the same day to Wednesday night. Hopefully, going forward, we'll see more of you here. And as an introduction, and many of you already know us, we're MarketX, a global investment platform helping family offices, ultra high net worth individuals to look at investments in both US, China, Southeast Asia. So let me first all introduce our guest today. And our speaker today, Mr. Hyuk-Jeen Suh, is the General Partner of SkyRiverVentures, a deep tech focused venture capital fund investing frontier tech in North America and Asia. He brings over 25 years of experience in the consumer electronics, biotech, finance, and semiconductor industries. Prior to SkyRiver, he has created and was head of the Samsung Ventures program in America, looking at many industries. Prior to joining Samsung, he was at J.P.Morgan investment banking, focused on TMT. And looks like we have two J.P.Morgan alums here, myself included. And thanks to Hyuk-Jeen for joining us today. Previously, he also has held senior position at MEMSIC and engineering position at Signum and Intel Corporation. He earned his PhD in electrical engineering from University of Illinois at Urbana-Champaign, and as his MBA from Yale School of Management, also a BS in engineering from Cornell. We joked around, how many degrees do you have in total between you and your wife?
9.
So without further ado, let me hand it over to Hyuk-Jeen to start today's investment presentation on deep tech investment post-COVID-19.
Thank you very much, Catherine. Let me try to share my screen here. Hold on for a second. I hope you guys can all see the slide.
Yep.
So thank you, everyone. As Catherine mentioned, I was the former US East Coast head of Samsung Ventures, which is the corporate venture arm of Samsung. And today's talk is going to be about some deep tech trends that are happening and some investment opportunities that are available, I believe, moving forward, especially with the COVID-19 situation as well. So a little about SkyRiverVentures, the fund that I'm in the process of raising. We're an early stage venture fund focused on frontier technologies and digital health. Our investments will primarily be in the Eastern United States and Canada, and some opportunistic investments over in Asia. And the thesis is to help companies that want to work with large corporations to enable that upfront so that we can help them scale and be more capital efficient and hopefully find some partners and potential acquirers upfront. Today's talk is going to be primarily about deep tech and what is deep tech? I define it as something that has a disruptive technology with a core defensible IP. One of a kind, where you need a master's or PhD level understanding to build a company in this space. It's not going to be a company that makes a mobile app for dry cleaning delivery or something like that. These are not the types of companies we're looking at. Some spaces that I consider to be in the area of deep tech, things like in AI, robotics, biotech, battery development, quantum computing, material science, and so on. And so with deep tech, I think you have to take a global perspective of it because deep tech is not based on boundaries by regions. It does apply globally. And if you look at this map here that was put out by Boston Consulting Group of where deep tech companies are visible, we see that the United States has the most number of deep tech companies. And what's also interesting is they pointed out China and Korea. And those two also rank, I would say, number 2 in Asia after the United States. And what's interesting here is that China and Korea show the fastest growth rate in terms of the number of deep tech companies that are being formed. And why is deep tech important globally is that, and unlike these other companies, startup companies, you do really need a large corporate sponsor to help you because, for instance, if you are going to do something in AI, you need a lot of data. and these big corporates have it, or you need a lot of compute power, right? The GPUs, graphic processing units, a lot of data centers, or access to companies that make large fabrication companies like Intel or Samsung to do next-gen photonics or next-gen AI chips. And so having this global perspective with a global partnership, I think is critical. So what's happening these days? There's a tremendous amount of data that is created. And post-COVID-19, it's accelerated even more. Right now, there's a 80% increase year over year in video consumption, for instance, on Instagram. And there's about 42% of people who plan to watch more stuff online this coming year. And as we all know, smartphone is the #1 device for data consumption, especially also on Facebook. And there's a 5x increase in gaze for videos versus static content now. And of those videos, 1 in 5 of them tend to be live. And for those live videos, there's a 10x increase in interaction with comments and things like that. And this puts a tremendous amount of data bandwidth pressure. And so there's an increasing demand for data storage, faster data transfer, lower latencies, and all of this has to be done at a lower cost. So the challenge we have is this massive infrastructure burden, and there's an opportunity for investments and for startups to do kind of real-time latency management and reduction, as well as data management, analytics, and things like that, and decision making. But how much data is actually being generated? I wanted to kind of give you a glimpse of how you can think about it. And I gave you, I guess, an analogy or a comparison here. There are, in our galaxy, roughly 100 billion stars in our galaxy. And as you know, that's on the order of 10 to the 9. In 2020, right now, the world is generating about 40 zettabytes of data. How much is that? It's actually 10 to the 21st power. That's a billion gigabytes. So what's the difference between a million and a billion, just conceptually? If I were to actually count the numbers 1, 2, 3, 4 every second up to a million, it would take me about 11 and a half days. If I count it to a billion, it would take me 31 years, right? Now you go from billion, gigabytes, you can get a sense of how much data we're actually generating. Beyond that, with all the IoT devices that are forming and all of that, we need IP addresses. So next gen, right now, the IP address, IPv6, there's 340 trillion IP addresses. And that's not a spelling error, that's 3 trillions. And that's on the order of 10 to the 34th power. And so with all this, there's a tremendous amount of data that's being generated. It is not possible, humanly possible, to deal with all of this. And so you need AI to actually manage all this information. The situation gets even more burdensome as we move on. In 2020, as I mentioned, we have about 40 gigabytes of data that's being created. But in about 4 or 5 years, we'll quadruple that. And so the problem now becomes even more critical. And companies, even today, are not able to analyze all the data they're capturing. And so as we go forward, it's going to be even more difficult. So there's this opportunity to figure out solutions to manage large data sets, or figure out a way to not deal with data and work with even small data sets. How do we do that? It's through AI, and that's where I'm going to be focusing most of my talk today, because deep tech is just way too broad to cover in one session. So there's this massive rise in AI, and in 2018 was the peak where most companies adopted AI into their company. And the top 3 industries have been in IT, in financial services, and then consumer goods and retail. But there are challenges associated with this, right? What are the top challenges in implementing AI, and what are the opportunities? Interfacing with these open platforms where you actually access data has been a tremendous challenge. It's actually the largest, bulk challenge that people face. And so in order to do that, you have to have solutions to integrate the data, residing the data in-house where it should be, or in the data center, and then deal with that, Secondly, not all data is evenly divided. For instance, you can imagine there's tremendous images about cats and dogs, but there aren't a lot of data regarding tanks, right, for military applications. And so you have to be able to create data to actually train the data, to train the AI. So this concept of synthetic data generation is going to be quite interesting moving forward. There's also this challenge of getting data that is unstructured. Traditionally, databases have been structured data, but now there's a lot of unstructured data. from tweets to, analysis reports and things like that. And so we need to figure out a way to unify all this information, what I call data ops. And then we have to do real-time machine analytics on this and decision-making. But with all this information, there's also biases, as you've probably heard online in the news about AI kind of going awry with all these biases. And so we need to understand why the AI is making or doing what it is doing. So this concept of explainability of AI and to generate additional data to balance the biases in the data itself will also be critical. And then a lot of times the quality of the output, right, or quality of the data can also be a challenge. And with that, we also need to understand why that is happening. So explainability will be critical moving forward. So what are the top use cases with this? Manufacturing, consumer electronics, consumer goods, financial, all of them have different reasons for why they're using it. But overall, across all industries, I would say the top thing is in quality control. To manage, preventive maintenances, to understand what's going on. There's also customer care. That's a big concern, number two, where there are companies like Bossa Nova and Relax who are doing inventory management and using robots to check if the stock on the floor is fully shelved or not. And there's also big concern around cybersecurity. And so there are companies targeting endpoint management as well as looking at the dark web to find out where hackers are hacking. And even just today, in the news, the Twitter accounts of Joe Biden here in the United States, Elon Musk, Bill Gates have been hacked this evening as well. And so these are big concerns that are happening real time. So with all this AI that's happening, can I have a use case here that I think would be relevant for this slide? There's a company called Tamr. It's a company that I invested in when I was over at Samsung Ventures. This company does data unification. So imagine you have all this unstructured data across maybe multiple business silos, and they don't communicate with each other, and they're stored in different areas. We need to be able to ingest this information. And we have to combine it, consolidate it, classify it. And in order to do that, initially, the data scientist might do a few clicks to show what it's trying to classify, for instance, and then Tamr takes over, does that for millions and literally billions of data points. And then through that, we're able to have a single source of truth, what I'll call a gold standard. From there, you can have additional customer insights and analytics. So Tamr has done this for various companies. Some of them are, for instance, at Thomson Reuters. They enabled a 10x reduction in data integration from a 6-month period down to 2 weeks. GM saved over $500 million consolidating their vendor list, right? There are many business units within, GE, from their, wind turbine business unit to their airplane division to the health division, and they're all buying, let's say sheet metal or screws, but they don't talk to one another, these siloed business units. If you can consolidate information, have volume scaling pricing, it helps GE to save money. Toyota uses it for customer insights. GlaxoSmithKline uses it to consolidate their clinical study to create next-gen drugs much quicker and faster. So with all this happening, there's also a change and shift in how we as consumers are behaving, especially online. So what is happening online these days? In 60 seconds, right, these are some stats that are out there. There's 1.3 million logins on Facebook. There's, close to 700,000 scrolling on Instagram. There are 200,000 tweets. There are 1,400 downloads of TikTok. All these things are happening. And so we're now in the age of instant gratification, where everything is really live. As I mentioned, people are interacting a lot more on these live streams and things like that. And so everything's coming live. And so who are doing a lot of this? A lot of the millennials are very, very involved. And so you have to capture the attention of these millennials. Why are they important? In 2020, millennials will account for half of the US workforce and 75% of the global workforce in the next 4 to 5 years. In addition to that, 85% of customer interactions now are going to happen without humans. And so you need AI to do that. And a lot of these millennials expect that. And it's interesting to know that with Facebook news feeds, with people being exposed to it, for 0.25 seconds, they can recall that information. And so these things are happening very, very quickly. And so how do we capture the attention of the millennials in a blink of an eye? right? With all the AI, you also need what I consider to be the next gen thing is emotion AI, right? You need to understand not only how people are thinking, but how they're feeling as well. And so this is a company that is based out of Boston, Massachusetts here, which is where I'm located, out of MIT, and it takes 20 different expressions and 7 emotions. They actually have the largest database of human expressions in the world. They've aggregated. So they sense and adapt to how we're feeling, how we're thinking, how our facial expressions are. And enterprises will use these emotions to gain richer insights into customers. And by 2024, 50% of online ads will be influenced by AI detection of emotions. So as the AIs continue to grow, as the neural networks get better, we run into bigger problems. So AI, as I mentioned, needs this neural network in order to train the AI to get better, to answer questions and things like that. But additional data, additional variables are added to this thing over time. And so the network continues to grow. As these things grow, there are a lot of redundancies in the network, and it becomes really, really big. And they all have to be basically on the cloud. And as these variables increase and these neural networks grow, it is not humanly possible to tweak the AI model by hand, by humans anymore. And so there has to be an alternative solution, either prune this network or to optimize it. And so a company that I know of, and next gen technology that's happening, is where AI actually creates AI, right? So you actually set the parameters, you set a platform where you want to do it, the number of computer chips you have available, the amount of memory you have, where you're going to actually deploy this thing. And then it builds the AI. It's not an optimized, it's not a shrinking of the existing AI solution. It physically creates a whole new network of AI, right, using this generative synthesis. And then from there, it optimizes for the edge or mobile or IoT or in the cloud. And then beyond that, once it tells you a recommendation, it is actually able to explain how it came to that conclusion. And so we're in this phase of now AI creating AI, and they've demonstrated this. And through this neural network, in terms of reducing the size of this AI network on the Google Net, is reduced it by 50x. On AlexaNet, it's on 462x reduction, right? And so we're seeing these amazing optimization that are happening. And this is all due to this new technology called Generative Adversarial Network, called GAN. And it's basically 2 AIs competing with one another. So in this case, you have what's called the generator, which is one of the AI, and the other one's called the discriminator. And so at the top, you see a training data set with real numbers that people have handwritten. And so the generator looks at that the number 8 in this example, and the discriminator looks at the 8. And the discriminator has learned, what does an 8 really look like? And the generator tries to fake the real 8 by creating some other solution that it created on its own, and the discriminator has to tell whether or not it is real or fake. And by doing that, the discriminator gets better, the generator gets better, and they compete with one another to the point where they cannot tell the difference between a real human handwriting and an AI-generated handwriting. And so through this, we've now created images. And so these are 8 images, and I don't know if it's possible or not to have people type how many our images are actually created by AI, but you can think about it in your head. Of these 8, which ones and how many are created actually by AI? So I'm going to give you a second. The answer is all 8. All 8 are actually created by AI, right? And so it's amazing some of the stuff that they were able to create. The lower right-hand one with the tennis ball is the one that looks a little bit strange. And it's because of what's called class leakage, where I think the AI confused the tennis ball with maybe perhaps a fuzzy, puppy. And so it created this tennis ball with a couple of eyes and a nose. But in general, it's done an amazing job, right? AI is also, with this GAN, have actually cracked codes. So a lot of times when we go online, we try to enter a website, they ask us to verify that we're not a robot by using this CAPTCHA image. Well, there's now, these universities have cracked this using a GAN solution and resolving the CAPTCHA in under 0.05 seconds. And so having, detecting whether you're a robot, an artificial intelligence, whatever, it really doesn't mean anything anymore, where AI can do this now. They've also now been able to show that AI can face more. So in the top row is a well-known U.S. Late-night TV host. His name is John Oliver. And this is a video and screenshots of various videos. And as he's talking, his face's expressions are changing. And they've actually been able to convert that to a Stephen Colbert video image. And Stephen Colbert is another late-night host. And just to give you an idea of what they can do, on a video frame, which is actually 30 frames per second, I have a video of President Obama in what we call a deep fake video. And you'll have to excuse some of the language that he used in here, but obviously President Obama is not the one saying it, but I just wanted to show you what it looked like. So, a second, let me see if I can turn this on.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this, simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you. Stay woke, bitches.
So this video shows, it's basically President Obama still image, and they've been able to use the AI to overlay, the gentleman's face and smile and talking onto Obama's face. And so they can create this, pretty easily these days. And so this gives you an idea of what GANs can do. And there are companies that are doing things in the space. For instance, the Script, Replica. These guys are actually doing synthetic voice to overlay on top of whatever you type. You take maybe 5-10 minutes of your voice recording, and then it synthetically generates your voice, and then whatever you type, it'll say it for you. And so it's a very common thing that is happening nowadays. Okay, but with all this advances, artificial intelligence isn't quite intelligent yet, right? AI can be fooled pretty easily. Right? And so this is an example where you have a panda bear on the left-hand side. And the panda bear, the AI assumed has a 57.7% confidence that that is a panda bear. And then with that, if we add a little bit of noise, a perturbation, you can see this little specks of pixels, and we multiply by 0.007, so a very, very small amount, and it outputs another image on the right-hand side. And that to the human eye, it looks exactly the same. It is a panda bear. For the AI, it doesn't classify this as a panda bear anymore, but it classifies it as a gibbon. A gibbon is a type of ape. And so with this just a small change, you can actually change the output of the AI. This is another example where a blueberry muffin is being confused with a Chihuahua dog, right? And this happens also. And so AI still has a long way to go, and these are some of the challenges that we face. Why does this happen? Because neural networks, for instance, right now, what I'm talking about is convolutional neural networks, probably the most used, has inherent flaws, right? So give you an idea, right? A convolutional network looks at a face, looks at the eyes and nose and ears, and it says, okay, this is a human face. But if I take that mouth and put it above my eyes, it'll still consider that to be a human face. Because convolutional neural networks, by definition, is a scalar matrix. It's not a vector-based matrix. And so it looks at features, but it doesn't look at the vectors. And for that reason, it can't differentiate between the left one and the right one I just mentioned. So there are new generations of neural networks that are happening, for instance, called capsule networks. And capsule networks take into consideration the spatial relationship between various features. And for that reason, it can differentiate between the left side and the right side of these face examples. And so these are things that are happening right now. It has not been fully deployed yet. And so this is really what I call like cutting edge deep tech that is happening. Another thing that people are trying to do is in the next gen is in edge computing. Edge computing is important because right now AI computation and training are done in the cloud, which is very, very process intensive. You need these special type of computer chips called graphic processing units, GPUs, and you need hundreds, if not thousands of them. To give you an idea, we had just talked about these photos that AI created. Google tried to create AI that has 512 pixel image. And they needed 512 what they call TPUs, is kind of a GPU chipset. And they used it for 48 hours to create a 512 pixel image. And that took close to 5,000 kilowatts of energy. That's equivalent to the electricity that an average American household uses over a 6-month period. And so doing edge computing has caused a lot of problems. It's trying to solve a lot of problems because a lot of the computation is so intensive. Another example of this is in ADAS solutions, or what we call autonomous driving assisted kind of solutions. And you need to have AI edge computing, done at the device or at the edge, at the smartphone or at the computer, at the car, because you have to have split-second decision making. The computation must happen on these areas, right, in the car, in the camera, because that decision, it takes too long to take that data, shoot it to cloud, process it, shoot it back to the car to know that you have to swerve to the left to avoid a car accident, right? And so there's a tremendous amount of demand for edge computing because there's limited power and space. A lot of the cars don't have infinite memory. And so how to resolve that? So this idea of edge computing is really, really important. And that's happening right now. And so this is an example of an image that I have, a video of the AI computation to detect things on the street. And this is quite difficult to do. I'm sure many of you might have seen these types of images online, where it's detecting a traffic light, cars, people, buses, pedestrians. All these things are done with time, but it takes a tremendous amount of compute power in order to do this. So what's beyond this even, would you say? And I would say doing edge computing to the extent of doing it actually on a mobile phone. And so there's a company I'm looking at, for instance, that is actually doing edge computing on the phone. It's not only doing ADAS solutions, but it's doing ADAS on a mobile device, including augmented reality, navigation, and mapping basically on an iPhone. And so this is a video that shows that. So it overlays, and you know exactly where you're going rather than doing a top-down view where you don't quite know what's happening. Because you're looking through, you can actually see which lane you have to be to make turns and things like that. And as I said, this was done on an iPhone, iPhone X and XS Max. And to be able to do this in the night where there's rain and fog and snow, it's very, very, very difficult to do. I'm not sure if anyone here can really appreciate how difficult this is. So this is now going to show some of the things that the AI solution has to be able to do in order to do this. So for instance, lane, to understand segment the lanes is critical. Again, this is done at around 75 frames per second on an iPhone, so double the traditional video frames. It has to understand what planes it's on, right? Object detection for individual things here, as well as you have to do semantic segmentation, which we'll show in a little bit as well. So this company has had to basically build a whole AR, augmented reality platform that's very, very light and very little compute power. On top of that, overlay all of the artificial intelligence as well. So that's kind of, really extreme, AI on the edge that's going to happen. But then what's beyond even that? And it's a concept called federated learning, where traditionally AIs, because the neural network is so big, they have been trained in the cloud. But now being able to train on the edge is going to be important. In this graph below, you'll see a solution at the top with a blue dot. And this is what we call a global state model that is deployed to all these different smartphones. And each of us use our smartphones, and we end up training the AI on our smartphone, but it maintains the data, the photos I take of a dog, or whatever it might be, stays on the phone. But because the algorithm is actually developed, it is now redeployed back into the cloud, and it creates multiple versions of it, because there are multiple smartphones that are using this global state version that's been modified. And then all of that is shot to the cloud to create a new state of a global phone model, and then that is then deployed back to all the smartphones again. So this concept of a federated learning is going to be really critical. And this is the next video is an example of where Motorola and a startup company here in Boston called Neurala is using very low power AI solution using computer vision to solve a problem. This company's technology was used on the Mars rover back in, I think it was 2009 or something like that, because the Mars rover has a limited amount of data and memory and processing power. And so they use this technology for the Mars rover to detect various types of rocks that they're picking up and things like that. So this is a video of Motorola using body cameras for police officers to identify people. And in this case, they're trying to identify a small missing child. Whoops. Let me see if I can do this. So this is all wonderful and great, but what are some of the limitations we have? The problem is that we need to develop all this AI, but there's a crunch. There aren't enough people who are knowledgeable of AI. Right now, there are over 140,000 job openings for AI specialists here in the United States. There's only 22,000 AI specialists who are actually looking for jobs. There's this massive gap that's happening. And so what are other companies doing? And what are some other interesting opportunities that are arising? They're now creating companies where AI is actually developing new models of AI to democratize it so that you don't actually need AI specialists at your company. Or you can deploy AI on your own by using their solutions. So companies like Data Robot, which has actually created over 1 billion, I believe, AI models automatically. And other companies like H2O AI and Data, these guys are all doing similar things. So where do you find these types of companies? A lot of people naturally say that you can find them in Silicon Valley, and I would agree. But I also would argue that that is not the only place where you can find AI companies. In fact, that's not the only place where you can find a lot of really interesting deep tech companies or companies in general. So I want to share with you a map of the United States and talk about where a lot of these companies are. So if you look at the West Coast, right, this is including all the way from Alaska down to San Diego, California, and look at the total dollar amount of funding that startup companies have received compared to the East Coast, from Maine all down to Florida. The West Coast versus the East Coast, 54% versus 34% is the difference between the number of dollars that are being invested by VCs, right? It's about 1.5 times more. If you look actually the number of companies that are actually being invested between the West Coast and the East Coast, it's actually basically the same. And so for every deal that all of the people who are looking in Silicon Valley, goes to see, and then they don't look at the East Coast, they're missing one deal. For every one deal you do or see, you're missing one deal. And having been on the East Coast, I can tell you there's tremendous amount of opportunities with universities like Harvard University, at MIT, UPenn, Cornell University, Columbia, Princeton, Yale. These companies are generating tremendous amount of technology here that is really incredible. And so with that, I'd like to just, close out the thing, and I'd be happy to answer any questions people may have, or Catherine, if you have any questions, I don't know how you want to proceed here.
Great, awesome. Well, thanks for the presentation. It's very informative. First of all, I'd just like to open it up. I know we already run over a little bit for the presentation, so let me just open it up. If anybody has any question, please raise your hand and I'll let you promote you to panelists so you can ask your question.
Hey, be like a panda, love it.
All right. Is anyone?
Yeah, there's
Great.
one question about the favorite area or sector that this is to both of the speakers. What's your favorite sector and what's your favorite deal?
I'm not sure if I quite heard. Are you asking what is the favorite sector?
Yes, what's your favorite sector and what's your favorite deal experience?
Yeah, right now for me, I think some sectors I think are pretty exciting right now is in automation and robotics, logistics. Right now, especially with the COVID-19 situation, there's a tremendous amount of automation that has to happen. And so for that reason, there's a lot of work from a logistics perspective, right? There's also a lot of things that are going on from a robotics perspective, two separate things. So logistics and automation, I think, are very exciting. And also in cloud solutions as well, because a lot of data streaming that's happening, there's a lot of information regarding cloud. And lastly, I would say in cybersecurity, because as we go more and more digital, right, there are going to be more and more hackers. And so there's a greater need for cybersecurity. So those are the two or three that I would say are pretty exciting right now. Hopefully that answered your question. Catherine, you're on mute, I think. I can't quite hear you.
Niraj has a question. Would you like to ask your question?
So I typed it out, but one of the things I thought about was that, people walk in these nice outdoor malls, particularly the warm areas like Texas, Florida, and, you walk by some of these fancy stores and, let's say somebody walks by the windows of the stores, and as they walk by, AI recognizes them and says, okay, I know your size is, so you're passing by a clothing store or a jewelry store, and it throws a nice diamond ring on your finger, so you could kind of see what you look like with it on it, something like that, or a nice fur coat, or obviously that's not for me, but that's for my wife.
Yeah. So the answer is absolutely there is technology like that, but it's slightly different than what you're saying. I mean, for me to just see without anything a diamond ring on my finger is not possible. But to see a diamond ring on my finger by looking through my smartphone or using augmented reality glasses, I can do that. Another thing that you can actually do, and there are technologies that are able to do this, is have a coating on the inside of a store. So imagine Starbucks store, on the inside is coated, it's transparent. But this coating enables Starbucks to actually put up signage, right? A signage that actually, normally they have, a 2-for-1 sale or whatever, 10% discount. But once they put that signage up, it stays up. But to have a dynamic signage is what these guys can do, and it's very low power. So you can have a colorful image to do that. And then by using a camera to do computer vision for body segmentation, see where you are, how tall you are, and as you're facing the screen or the window of a shopping a mall, they can actually display your image through kind of a one-way mirror-like display and show the clothing on you. That is absolutely possible today.
Oh yeah, who's doing it?
There are a lot of companies. There are companies I think it's called, I think it's Fashionista, I think is one of them. There's another company that does the actual screen. I think it's called Lumitoon is another one. There's, I can't think of all the other names of other ones, but there are a number of companies doing things like this.
Yeah, it looks like Calvin, you also raised your hand. Do you want to speak?
Yeah, thanks so much. Excuse me. Great talk. Thanks so much for that great tour of all the interesting work happening in DeepTech. You mentioned that SkyRiver has a unique model around collaboration between startups and large corporates. Could you say a little bit about, from your experience, what are best practices of that engagement, how young companies, especially deep tech companies, can work with bigger partners or customers?
Yeah. So first of all, in order to engage with large corporations, it is very hard to do that when you have nothing but just an idea. And so to engage with them when you at least have a minimum viable product is good, or at least have an idea of what the minimum viable product would be. And so engaging with them and finding out, what are the main issues you have, right? And then finding out what they're looking for and finding out those specs, and then designing the minimum viable product or your alpha beta product based on that, and representing that to them, so that they can get a feel for what you're actually doing is important. Secondly, I would say a lot of startup companies, they're very, very focused on just building this one little thing, and they haven't quite thought about scaling to the scale that large corporations need. That is the biggest, I would say, failure of most startups that I've encountered, is that, for instance, if they do AI, natural language processing in English, wonderful. Then Samsung asks, well, can you do this in 100 different languages across 150 different carriers, right, in 100 different countries? And the company will probably say, no, we cannot. Well, the next question is, okay, how fast would it take you to scale? If you're doing now, a domain-specific, natural language processing for sports, about soccer, then I want to now do the same natural language processing for cooking. How long would it take you to develop that AI solution for that, right? And so by creating a platform that enables you to do that very, very quickly, will be far more appealing to large corporations, right? So that's what I would also recommend. So one, developing something to scale, and two, try to meet with corporations as early as possible to get feedback on what they would look for in a minimum viable product.
All right, so on behalf of the audience, I got a question. So right now, obviously, we have some of these challenges in AI. We've seen like companies like OpenAI really pushing the frontier of AI and deep tech. What do you think are some challenges in this field, and how about like the ethics of AI? Can you, give us some examples of that? That would be great.
Yeah, so I think, this coming year, I think this will be a huge, huge issue, and there'll be a big push for it, is to deal with biases in AI, right? To, when you look at people, having enough balanced data to show the different things, will be critical in terms of identifying a person. How should that person look? If a police officer with a body camera is looking for an individual, is it biased because there are more African-American people who are typically jailed than a white Caucasian male? And so dealing with these biases will be critical. On top of that, having the ethics, an ethics committee, if you want to call it, at these companies or at a national or government level will be critical. And so I think that's going to be one of the big pushes for this coming year, because now we're talking about people, for instance, using facial recognition in some parts of the country here in the United States, not the whole of the United States. Facial recognition is banned from being used because they consider that to be a privacy issue. And so where do we draw the line? And so this ethics will be a big problem moving forward.
Great. So I will, leave the audience to ask questions again. If you have any questions, please type it or raise your hand or unmute yourself. I think it should be pretty, I think everyone's a lot to talk right now. Or I can add another question. I'm personally very curious. given the US-China trade war going on. What's your take on the AI development war between US and China at the moment?
Yeah, this is a big problem right now, because as there's a a technology battle that's happening, maybe even a political battle that is happening, but it's fragmenting the global development of all technologies. And right now, as it pertains to AI, US has made tremendous progress in this field, but because China has many more people, there's a lot more data that's being generated, and privacy is a little bit less of a concern. And so there, for instance, using cameras around the country for facial recognition and things like that, for digital payments and so on. It's a tremendous amount of data that's being generated. And so I think, in the near future, China, may even exceed what's happening here in the United States. And as the two countries duke it out, we may end up having AI solutions or other types of technology solutions with different standards. When you have two different standards, the global pace in which development happens will slow down, which it'll conflict. It's like in the day, maybe 10 years ago, whatever it was, when we had CDMA and GSM technologies where they were not compatible. It made things very, very difficult for consumers. You have to have two different phones when you're traveling and so on. And so those types of standards are going to cause big issues moving forward. And it's not just in this space, but in other types of things like in quantum computing as well, in biotech, all of these things where you really need to collaborate to actually accelerate the development. But I think that's going to be slowing down because of what's happening right now.
Thank you. I've got a question. As you're investing, it'd be interesting to know your rubric for picking winners.
Yeah, the number one thing for me has always been the management team. And when I say that, I mean the team has to be knowledgeable in this space, obviously in this area, but they also have to be super aggressive. A lot of people I've met, they don't have that fire desire to actually move things along. I especially see that in the academic world, where academic research scientists are a little bit at a slower pace. And so a management team, that is, top notch is super important. And then number two would be the actual technology or the business idea. And so there's a saying that goes, if you had a choice between an A grade team and a B grade idea versus a B grade team with an A grade idea, I would always choose that A grade team with a mediocre idea, because I know they can always turn things around and take a new business model or a new technology if they need to. And I've seen just about every single company I've invested in where the business model that they initially had was not the business model that they exited with. And so it's the team that really, really matters. And doing a lot of reference checks and understanding and getting deep into how they're working, and also the dynamics between the team members themselves are also quite critical. I use an analogy that if you look at carbon, it's carbon, and because of the structure, how it's formed, you create charcoal or coal. It is dark, opaque, and soft. If you take that same carbon and you structure it slightly different, it becomes a diamond. It's transparent, hard, right? It's exact opposite of a coal. And it comes from the same people, the same individual components, but the way they are networked together makes a huge difference. So the way how the management team really works together is super critical for the success of a company. Hopefully that helped.
That was a brilliant answer. Thank you.
Great. Do we have any other questions from the audience? Well, I guess I'll, chime in for now. So given that right now we have a crazy, pandemic going on, what do you think are some top predictions for 2021? Hopefully things will be better. So please give us, your predictions, whether in AI or other trends.
Yeah, for predictions for next year, as I mentioned, this emotional AI thing I think is going to be really, really big. I think what I call hybridization of security protocols, I think are going to be really big, meaning just about, I think 70–80% of all companies are using various forms of cloud solutions, whether it's a Amazon AWS solution or a Microsoft Azure solution. And there are security protocols for each of them. And a lot of them are doing, are not willing to put, really, really high security of the data in the cloud. So it's on-prem, locally. And so although there are security protocols across, for each of these things, there really isn't a standard security protocol across all these things. And so I think that's going to be a big, big issue moving forward. I think there's going to be a lot of development moving forward for that. Secondly, I think cybersecurity and the whole thing about deep fakes is going to be really critical moving forward as well. I think there'll be more hacking that's going to happen this coming year. And so finding solutions to deal with that will be critical. And so you'll now have not hackers hacking into systems, but you'll have AI hacking into systems. And the only way to defeat that is have AI compete with another AI. And so I think that'll also be an emerging technology that's going to happen this coming year. Oh, Catherine, I think you're on mute again.
There we go. So I think that's all my questions. Do we have any other questions? I'm happy to, introduce and also show everyone Hyuk-Jeen's presentation afterwards. So I will wait for a second to see. Oh, Calvin, there you go. Can you talk?
Oh, sorry, I had it on mute as well. Another question on my side. How do you think about the capital intensity for deep technology startups? Some of them can be pretty capital intensive in scaling.
That's a great question, Calvin. So deep tech tends to be quite capital intensive. At least for my fund that I'm creating, I'm actually looking for what I call capital light deep tech companies. What I mean by that. So robotics, as I mentioned, is a big deep tech company, a deep tech industry, right? And so there are companies that are there to build massive robots, and that's very, very capital intensive. But along with that, you need a lot of different things. For instance, you need object detection. You need computer vision to actually detect where an object is. That's very capital light. You actually need a solution not only to detect objects, but do object avoidance or real-time pattern direction. Meaning, if I have an arm that's moving to move this piece of whatever I have in my hand over here, and something's blocking the way, it needs to do real-time, pattern detection to figure out which path I need to go. And so this is all a software solution. And so companies that are trying to be very capital efficient, I think they will end up being more software oriented, or they will target a very specific niche within that space. For instance, a robotics company not build the whole robot, but building just a specific type of gripper technology that will enable them to manage all forms of products. For instance, a gripper that does, hard ceramic type of grippers it can grip something. But the problem now is that the width of the gripper is too narrow to pick up something that's even bigger than the gripper. So now they have solutions for robotic hands that actually use a suction cup to grip this thing. But then what do you do if it's a porous material, like a piece of clothing? Or what do you do for an egg that you're picking up? And so a new robotic hand that can grab these things is an example of a much less capital intensive solution that is really, really critical and important for the robotics industry. Hopefully that makes sense.
Yeah, that's great. Thanks.
So let me, I think that Anthony just joined us as well. I know it's a late night today, so does anybody else have questions? You can raise your hand or unmute yourself. Well, I will, first of all, we are helping investors looking at various companies, and overall, we look at a lot of AI enterprise SaaS that leverage deep tech to solve world problems. So what do you think are, right now, based on the areas you're looking at, what are some of the most exciting opportunities you see coming up or right now in the pipeline?
Yeah, one company that I just recently invested in is in the area called multi-party computing. And what that is it's almost a complement or the antithesis of blockchain. And what I mean by that is people trust blockchain because it's fully transparent. It's a ledger system. And so it's fully transparent. You know who has touched this blockchain effectively, right? So that builds trust. Another way to build trust is to be completely opaque and not share anything, right, that you need unless you want to share a specific thing. And that's what this multi-party computing does. And so imagine, Google and Apple trying to do contact tracing of individuals who are customers of theirs, right? People who have iPhones versus an Android phone. How do we make sure we collaborate and bring all these people together? We could use blockchain, right? But another way to do it is, okay, I keep my Google customers in my Google database, and Apple, you keep yours in your Apple database. And then we have a black box in the middle that allows you to query that black box, say how many people who are the age of between 18 and 34 living in California, right? And moved here in the last 2 years. And this black box query can aggregate this information and do it. But the interesting part about this is that normally in order to get access to that information, you have to first encrypt it to make sure it's not hacked. Then you transfer it. Then you have to decrypt it to actually see the information. This multi-party computing technology enables the people to maintain and keep that in an encrypted form, never decrypted. So even after you transfer it, it's never decrypted. You can extract information to allow collaboration and not share the full data. And so I think that is really, really interesting stuff that's happening. And this is really relevant for, as you can imagine, in the healthcare system, as well as for financial technologies, for trading and things like that. And so those are two areas that this company that I invested in is working on.
Great. Well, so we are kind of, after the clock. It's 9 p.m. right now. It's pretty late on East Coast as well. So I will ask one more time if anybody has any questions, whether it be for areas of AI, SkyRiverVentures, or MarketX, please let us know. Follow us next week. We will have another one on Wednesday night or, Thursday morning Asia time. So please give us a shout if you have any questions. Well,
I have one question. Thanks for everything. The presentation was really good. I was wondering if you considered any technology of AI. Now I just see there's a lot of technology heading to the space technology. So was there any thoughts you implementing this to the space technology that's trending?
Yeah, I mean, there's a lot of solutions that are happening in frontier technology, space technology that's happening. It ranges from even AI being used to create next generation computer chip design that is specifically used for really intensive computing, and so things like that could be applied to space. There's a lot of work being done for designing optics for telescope technology that are used in space. There's also technologies that are being used, what we call swarming technologies, where you have one autonomous vehicle, whether it's a space vehicle or a drone or whatever it might be, and it needs to now collaborate with a second, or in fact 1,000 drones or 1,000 satellites. How do you actually make that happen? And that's a big problem, for instance, for small drones, because they have two big issues. One is a battery issue. They can only fly for about 15 minutes. And two is a payload issue. They can only pick up about 5-10 pounds of material. They have to be able to collaborate, and as one runs out of battery, they have to come back, while the other one goes over. They have to tag team. And so this type of technology directly applies to satellite technology as well. As I mentioned, even in this demonstration today, I talked about Neuralink, where it's using computer vision with small compute power and low memory on the Mars rover to sample rocks and things like that. And so AI is used everywhere, and a lot of the simulations that are used for trajectory and things like that will also, I believe, we will use AI, and that's also being used for other places like in drug discovery and also for new compound material discovery as well. So there are companies in here, one out of Harvard University, that is looking at new compound materials, ranging from novel battery materials for space, and also another company that is looking at it for metabolics for drug discovery as well.
Thank you so much.
Thanks, Hyuk-Jeen, for a very informative answer. And it looks like we're a little bit over time. So again, thanks everyone for joining today. Again, MarketX helps looking at AI, but also areas in fintech, next generation transportation, village fintech. Actually, is a pretty interesting area we will go through through another webinar we have planned. Again, thank you for everyone joining from over the world. We will see you next time.
Thank you very much. Take care.